We're looking at data transformations here, and I'm going to be referring to measures of center, and I'm going to be referring to measures of spread. So it's really important that you understand that when I'm saying measures of center, I'm talking about the mean and the median, but I'm also talking about the quartiles, the min, and the max. And then if I'm talking about measures of spread, that's including the IQR, the range, and the standard deviation. And standard deviation is a measure of spread. You might not really think that it is, but standard deviation is measuring how far away your points are from the mean, or you could say how spread out your points are from the mean. Okay, so it really is about spread, even though you might not think that. The reason you need to know data transformations is think about if you had 100 or let's say 200 pieces of data. You typed all 200 pieces of data into your calculator. You did menu 411 and you got all your 5-number summary and your mean and your standard deviation. And you thought everything was great. And then you realized, oh my gosh, I made a mistake. I forgot to calibrate the scale. Everything is off by 3 ounces. You could theoretically correct all 200 pieces of your data by subtracting 3 ounces from them all, then retyping in all 200 pieces of data into your calculator, doing menu 411, and getting your 5-number summary and your mean and your standard deviation. That's kind of a huge waste of time. If you understand the behavior of measures of center and measures of spread, though, then making that correction is going to be a lot faster. So here's how it works. Let's say I've got hockey players' heights. I'm going to do this. Okay, so these heights are given in inches of hockey players. Now I could easily figure out that the median would be the center in between these two values, which is also going to be a 72. And then what I could do is I could split like this, hang on, and then find that the first quartile is 71 and the third quartile is 75, and I've got the min and the max. So I could do that easily without the use of a calculator. But if I need the mean, well, I could do the mean without a calculator too, but if I need standard deviation, that would be the big one. I wouldn't want to do that by hand. So I would do menu 411 and I would get all these values. Okay, now let's say I decided, oh, actually, I want my hockey players to put their skates on. So if I put their skates on, now they're all going to go up, all their heights are going to go up by 2 inches. If I make a correction to all these values and add 2 to every single one of them, and then do menu 411, here's what I get. Okay, so I just want you to look at what happens to our measures of center and what happens to our measures of spread. Oops, sorry, that's kind of in the way. All right, here are measures of center. All right, these are your measures of center. Look at what happens to those measures of center as we had to add 2 to every piece of our data. You'll notice that the min went up by 2. Q1 went up by 2. All of these go up by 2, all the way up to the max went up by 2. And the mean up here was 72.666. Now it's 74.666. So the measures of center, they all increased by 2 as well. Just type that in. All right, now what happened to our measures of spread? Well, remember measures of spread are IQR, range, and standard deviation. So let's take a look at what happened to the standard deviation. Standard deviation on the original data was 2.33809. Standard deviation after we added 2 inches to all the players was still 2.33809. It didn't change. Let's look at IQR, for example. IQR is Q3 minus Q1. So in this case, it would be 75 minus 71. We get 4. Look down here at the IQR. IQR here would be Q3 minus Q1 again, so that would this time be 77 minus 73, also equals 4. The IQR did not change. Same thing with the spread. Spread from min to max is 6. Here, spread from min to max is still 6. So nothing changed for the measures of spread. They stayed the same. Let's add that down here. So if you are adding or subtracting a value to all of your data, the measures of center will go up or down by that value, but the measures of spread will stay the same. Okay, now this example, I have some weights of babies given in pounds. And if I put those in my calculator, did menu 411, this is what you would get. But now if I decide, okay, I don't want my weights in pounds, I want my weights in ounces, there's 16 ounces to a pound, so I would need to multiply all of those values by 16. So if I were to do that, multiply them all by 16, put them in my calculator, do menu 411, here's what I would get. All right, so again, let's look at the measures of center first. So measures of center, those are our 5-number summary and our mean. Compare them down here. Oops, that one didn't go all the way. There, and our mean. So our mean was 7.94, now it's up to 127. All of these values down here, they increased quite a bit. So our measures of center, if you look, they all are multiplied by 16. Okay. Now look at the measures of spread. So measures of spread, again, would be the standard deviation, the IQR, and the range. Standard deviation originally was 1.11, now it's up to 17.856. So that too got multiplied by 16. It did not stay the same. You could then look at the IQR. IQR for the top data was Q3 minus Q1, so that would be 8.75 minus 7.25. IQR down here, Q3 minus Q1 would be 140 minus 116. So you'll see that the IQR also got multiplied by 16. So the measures of spread are also getting multiplied by 16. So to summarize, when you're adding or subtracting, you could say or subtracting, a value to every number in a list, the measures of center will increase by that amount. But the measures of spread will stay the same. If you're multiplying every number in a list by something, the measures of center will get multiplied by that amount. Okay, and the measures of spread will get multiplied by that amount as well. All right, I think you get the general idea. Okay. Okay, this is the last part, and actually this is the most important part because what we're going to talk about now is going to continue on for the whole rest of the year. So I really want to make sure that you understand this next part. The idea is that you might need to compare two different things that might come from completely different distributions. So it might come from two different groups or two different populations. So for example, I could ask who's taller relative to their gender? An 80-inch tall guy or a 76.5-inch girl? Well, obviously the guy is taller, but that's not what I'm asking. I'm asking who's taller relative to their gender. Well, that comes from two different distributions. The distribution of heights for females is different from the distribution of heights for males. So we'd have to look at those two different distributions separately. Same thing down here. Scoring a 610 on the SAT, how does that compare to a 24 on the ACT? Those are two different tests. So how do you compare them? Well, the answer is you need to standardize those test scores. And a standardized score is called a z-score. So in this yellow box, write down that formula, okay? That formula is not on your formula sheet, but you do need to memorize it. And luckily for you, you're going to be using this so much that you'll have it memorized in no time. But the idea is that X would be your score on the test, like your score on the ACT. This is mu. This is the symbol for the population mean. And we would know what that is. We would be able to take everybody's scores from the ACT, everyone that took the ACT, and average them. That would be mu. Sigma down here, this is lowercase sigma. It's a Greek letter. This is the symbol for standard deviation for an entire population. Okay, z-scores tell you how many standard deviations above or below the mean that particular score is at. How far above or below the mean you're at. How many standard deviations. You can compare data from two completely different populations or two completely different distributions if you standardize those scores. And if you look at the z-scores, whichever one is higher, that will be the better one. Okay, so for example, let's look at the SAT and the ACT. So this is saying, I gotta grab a pen, I think. I'll try to get the pen to work. It wasn't working very well for me before, but I'll give it a shot right now. This right here actually means something. If it's telling you that the SAT scores are N, 500, 100, the N means normally distributed. Okay, normally distributed means that it follows that kind of like bell-shaped curve. The first number listed is the mean, that mu. The second number is the sigma, the standard deviation. So SAT has a different mean and standard deviation than ACT. So over here, ACT is also normally distributed, but this time the average, the mean, is 21 and the standard deviation is 3. Okay, so we're going to need to go make a z-score for both of them. Okay, so for the SAT, just a sec, I got to get that pen again. Okay, SAT, if we're finding the z-score, this pen is just really not working very good, but bear with me. It's just going so slow. Okay, the score that the person got on the SAT was a 490. So we put that in for X. The mean for everyone in the whole population is 500. And then the standard deviation is 100. Okay, so type that in your calculator. And you're going to get negative 0.1. All right, now let's do ACT, z-score. All right, so the person scored a 20 on the ACT. The average is a 21. And the standard deviation is a 3. So type that in. And the z-score for this is negative 0.33. So what the z-scores tell us is that this person is below the mean, but not by much. 0.1 standard deviation below the mean. This person is also below the mean. Again, not by too terribly much. They're about a third of a standard deviation below the mean. So which person is less negative? Which person is less below the mean? This person right here. This z-score is a larger value, so that person would have done better relative to that test.